Okay, here's an introductory word problem. We're going to start out by just kind of talking about components and just if I were to give you an angle measure and a force, or in this case a velocity, then what would the components of the airplane be? And it would look like this. So if we kind of just draw out, what I want to remind you of that the bearing, so here bearing of 65 degrees, that's not just 65 degrees naturally. So we're going to kind of draw the bearing. So if we draw a coordinate plane, set it up like this, then what we have here is, if I were to kind of draw this out like that, then the angle you see at the top, this is bearing of 0 degrees. So if you're talking about bearing, then this is the angle around the clock, or around the coordinate plane in clockwise fashion. So this would be where you get 65 degrees there. Sine, cosine, and tangent don't really like to work with that kind of angle, so we have to go backwards and find out the fact that if that's 65, then what do I have to add? 65, subtract away 90, so you'd end up doing something simple like 90 minus 65. So this becomes 25 degrees here. The magnitude of this vector is 500. So you can think about the length of the vector is 500. And here, we're going to draw this out. We're going to create our little right triangle. The question is, what is the x component and what is the y component for this situation? So we have our airplane. It's bearing 65 degrees, and we have its magnitude at 500 degrees. So it's bearing this direction, which you could talk about it in bearing terms of 65 degrees, or it has an angle of 25 degrees. Either way you want to do it, you need to be aware of whether you're dealing with bearings in this case, or you're going to be working with angles. Because we're going to be using sine, cosine, and tangent, we have to know the true angle, not the bearing. So once I get here, then it allows me to kind of go ahead and set it up. My x and my y values are going to be just like this. So x has to do with cosine. So we're going to say it's going to be 500 times the, what's that, cosine of 25, and 500 times the sine of 25. This is going to give me the two component forms of the vector, and so we can work it out this way. We know that the x coordinate is going to be 400. Let's see, I'm going to do that. It's going to be 453.15. And the horizontal, or the vertical component, excuse me, is 211.31. So if I write this, the component form of this vector looks like this. So you got a vector of 453.15 and 211.31. So this is finding the component form of a vector, or in this case, it's a plane in form. So if I kind of make sense of this, what you're looking at is that the plane is moving horizontally in this direction, 453 miles per hour. It's moving this direction, 211.31 miles per hour. Now the question would be, other questions I could ask about this is, if I had another force acting on the plane, saying pushing it this way or pushing it this way, what would we do? And we're going to look at that problem in a minute, but we would find that component and we would essentially add these two components together.